Dear friends, today we shall see the next part of the module 4. So under module 4, as you are aware, we have three chapters. One is virtual memory management and another related to file system management. Now we have already seen what is virtual memory management, what is demand paging, what is copyright, copy on write, what is page replacement, and all those things. So in this video lecture we shall see what is file system, what is a file, how to access different methods of file systems, then directory structure, file mounting, file sharing. So first and foremost thing we need to know is what is a file. A file is nothing but it is a named collection of related information that is recorded on secondary storage device. That is, you have an operating system, you have a file system. Under file system you can have various organization, that is your directories. Inside your directories you can have n number of files as shown in the diagram. So next we shall see what are the different types of attributes for a file. There are totally 6 attributes for a file. The first one is name. What do we mean by name? Name is nothing but it is a symbolic file name, that is, which gives the information which is kept in human readable form. That is, whenever you open any type of text document or your Word document or notepad, anything, you save it using a file name. So using that particular file name, you can come to know the details of that particular file. So that name will be always in the form of human readable format. Next, second attribute is identifier. What is this identifier? Identifier is nothing but it is a unique tag, that is number, that identifies file within the file system. It is a unique tag, that is number, that identifies file with file system. Next, type. This information is needed for systems that support different types, that is different types of files. It can be your text file, it can be a Word file, your entertainment file such as your video file, your audio file, all those types. Next we shall see the remaining 4. Continued with the attributes. Location. What is the location? Where exactly your file is there. That is, this information is a pointer to a device and to the location of the file location on that particular device, where exactly you have stored your file. Next, size. The current size of the file is measured in terms of bytes, words or blocks. It tells the size of particular file, whether it is in your MB, KB and so on. Next, protection. Next attribute is protection. How do we give protection to a file? The access control information determines who can do writing, reading, executing and so on. That is your read permission, write permission, execute permission, as you are already aware of your CH mode, change mode with your permissions. So that is how you give your protection, that is for your group, owner and users. Last attribute is time, date and user identification. It tells when the particular information, this information gives us or tells us that when exactly the user has created the file, at what date, at what time and who is the particular user. That is what is given here. The information may be kept for creation, last modification and last use. These data can be useful for protection, security and usage monitoring. So these 7 are your basic file attributes. Next, now we shall see what are the operations that we can perform for a file. As you can see here, we have 6 types of operations. So as I told you, file is nothing but collection of data. You can tell it as an abstract data type also, which is incomplete. Abstract means it is incomplete. You can always add data to your particular file. So as you can see here, we have 6 types of file operations. The first one is creating a file. Creating a file, there are 2 steps which are necessary to create a file. The first one is, first you need to check the space. The space in the file system must be found for that particular file. The second one is, an entry for the new file must be made in the new directory. Next, entry must be made for a new file and it should be entered into the directory. That is, whenever you create a particular file, in order to organize that particular file, you can have directories. Next, writing file. What do we mean by writing a file? In order to write the contents onto a file, we need to operate, or this is one of the operation with respect to file operations. Next, reading a file. Based on the protection given, you can read from a file, and also you can use a read pointer in order to do this particular operation. Next, we have reposition within a file. Reposition within a file. Reposition within a file means the directory is searched for the appropriate entry, and the current file or position pointer is repositioned to give a value. Repositioning within a file need not allow any actual IO operation. This operation is also known as file seek. It is also known as file seek. Next, deleting a file. To delete a file, we need to search the directory for the named file. We need to first search the directory where exactly the file is located. After searching the directory, based on the associated entry, based on that particular directory, we will search the directory and next go inside and delete that particular file. Next, truncating a particular file. What is this truncating a file? Truncating a file is nothing but the user may not erase the contents of a file. The user need not erase the contents of a file, but keep its attributes as it is. That is a major difference between your deleting a file and truncating a file. Deleting a file, the whole file can be deleted, whereas truncating a file, the user may want to erase the contents of a file, but keeps its attributes as it is. These are the 6 file operations. So please don't get confused between your file attributes and your file operations. So file attributes, there are 7 attributes, and file operations, there are 6 file operations. Next, we shall see how to open a file, or when we want to open a file, what are the things we need to keep in mind. First is, we need to keep in mind of a file pointer. What is this file pointer? File pointer is nothing but a pointer to last read or write location and per process that has the file open. Whichever file we open, we will be having a file pointer located with it. Using this particular file, we will start reading or will perform writing as per the instructions or as per the need of a particular user. Next, file open count. What is this file open count? The counter of number of times a file is opened. How many times a particular file is opened? Say suppose you have a file called abc.txt. Using this file count, we can come to know that how many times a particular file abc.txt is being opened. And next, disk location of the file. Cache of data access information. That is, how many times the data is being accessed from that particular location. Next, access rights. Access rights, each process opens a file in its access mode. This information is stored on the per process table. There is something called as per process table, wherein it will access the mode information, like in which particular mode is the file opened. What is this file mode? What is this access mode? In next slides, we will study what do you mean by accessing a particular mode, file mode. Next, we shall see file types. As I told you, you are aware of different types of files. File type, there are executable files, object files, source code, batch files, text files, word processor, library files, print or view files, archive files, multimedia files. So executable files, as you are aware, the extension will be .exe. Next, object file .obj. Source code, it can be any of your languages such as your C language, your Java, your assembler, and so on. Batch files, your extension can be .bat or .sh. Text file .txt, .doc. Word processor, it can be doc, that is with respect to your MS Word files. Library files, .lib files. Print or view, it can be your .pdf or .jpg file. Archive files, zip files, your tar files. Multimedia files, any of your entertainment, that is your MP3 players or your AVI files. So these are certain types of files, and here in this table it will explain what is the file type, what is the extension, and what is the function for each and every file. Next we shall see the access methods. What are the different access methods? We have three types of access methods. One is sequential access file, that is sequential access method. Next is direct access method, and one more is other access methods. First, if we see sequential access method. Sequence means, as the name suggests, sequence means in an order. If you open a file, you are going to read the contents or process that particular file in an order. So the information in the file is processed in an order, one record after the other. One record after the other. Example can be your editors or compilers, which usually access files in this fashion. Say suppose you take your compiler or your editors. When you open any of the editor, line by line you are going to write the contents into that particular file. Whereas your compiler, it is going to check line by line, that is starting from 1 till the end of that particular file. Sequentially it is going to check the particular given file. For this we can make use of pointers called as read next and write next. So as you can see here, the current position of the file is here. This is your beginning of the file and this is your ending of the file. So current position is here. Whenever, say suppose abc.txt is a file, if I open that particular file, current position will be here. From here I can either read or write into the file using my read next and write next operation pointers. Read next and write next operations. So this is your current position. So based on this I can use read next or write next. Read next, what it will do, it reads the next position, it reads the next position of the file, and your write next, it appends to the end of the file. It appends to the end of the file and advances to the end of the newly written material. That is towards this side, either I can read or write based on the user's convenience. But remember that it is done in an order, it is processed in an order, that is one record after another, one record after another. Next, direct access method. Direct access method, it allows random access to any file block. It allows random access to any file block. That is, here we always convey using blocks. We always use the term called as blocks. As you can see here, for direct access method, the file operations must be modified to include the block number as a parameter. To include block number as a parameter. Thus we have read n, where n is nothing but number of blocks, rather than read next and write next. As you can see here in the earlier, that is your sequential access, we made use of read next and write next as the pointers in order to access the file, whereas here we will be making use of block, that is n. N is nothing but the block number. So that is, say suppose there is a file ABC, that particular file can first read block number 10, then read block number 20, 30, then read block number 13. It is in a sequence, that is using blocks. It is not in a sequence. Using block number as a parameter, the file is being accessed here. Next, other access method, that is your third method. In this particular access method, what we can do is, this structure allows us to search a large file when we are trying to do some IO operations, when we are doing some IO operations, when we are doing certain IO operations. What is this? With these large files, we can do, or we can create the index file itself. The index file itself may become too large to be kept in the memory. So one solution to this is to create an index. As you can see here, we have created an index here, which will tell that index for the index file. The primary index file would contain pointers to secondary index files, which would point to the actual data items, That is, say suppose I want to access this file with name Smith. This is my index file. The contents will be Smith, John, social security, age. That is the different attributes of this particular file called Smith. So this is your index file and this is your relative file. So using this particular index, I can go here with using your logical record number. That is, some number will be given. Based on that number, I go here and I see the different attributes or contents of that particular file. Now, till now we have seen what is file attributes, what is file operations, different accessing modes and file types. Now we shall see what do we mean by directory. So directory is nothing but a collection of nodes containing information about all files. Both the directory structure and the files reside on disk. Backups of these two structures are kept on tapes. Next, we shall see what is disk structure. Disk can be subdivided into partition. Disks or partitions can be RAID protected against failure. What is this RAID? It is again a storage device. RAID is a storage area network, wherein you are going to store the contents of your file. Next, disk or partition can be used raw without file system or formatted with a file system. Partitions are also known as mini disks or slices. Entity containing file system is known as volume. What is this? We'll see in the next slide. See, now if you see here, we have directory, we have file, we have directory, we have file. I am going to divide this into two things. This whole thing is called as a disk, and here if you see here, it is partition A and partition B. Inside partition A, you have directory and respective files. Inside partition B, you have directories and respective files. Next, we have here, if you see, we have again next one more directory, wherein it is partition C, disk 2 and disk 3. If you see here, it is disk 2 and disk 3. Next, we shall see what do we mean by operations performed on directories. As we have learnt different operations performed on a file, we have operations performed on directories also. The first operations are search for a file. That is, search for a file is nothing but we need to be able to search a directory structure to find the entry for a particular file. Next, create a file. Create a file means new files need to be created and added to that particular directory. Next, delete a file. Delete a file when a file is no longer needed. We need to be able, or we should be in a position to remove it from the particular directory. Next, list a directory. We need to be able to list the files in a directory and the contents of the directory entry for each file in the particular list. Next, rename a file. Renaming a file, this is nothing but because the name of a file represents its contents to its users, we must be able to change the name when the contents or use of the file changes. Renaming a file may also allow its position within the directory structure to be changed. Next, traverse the file system. Traverse the file system. What do we mean by traversing the file system? If in case I need to traverse a file system, that is inside directory, one directory inside the other directory, I should be in a position to go inside. Say suppose A is one directory, B is another directory. Inside this directory I have another directory called as C. If in case I want to search this particular directory, I should be allowed to traverse from A into B and then into C. That is the meaning of traverse the file system, and then access the files present inside the C directory. Now we shall see the common schemes for defining the logical structure of a directory. Logical structure of a directory. What are the logical structures of a directory? First one is single level directory, two level directory, three structured directory, acyclic graph directories, general graph directories. General graph directories. General graph directories. First one is single level directory. What do we mean by single level directory? Single level directory is nothing but it has access for all the users. Single directory for all users. As you can see here, I have a file here. All these are called as files. For each and every file, there is a directory. For each and every file, if you see here, there is a directory. Say suppose this is abc.txt file. abc.txt file. I can tell that this particular abc.txt file, is under the directory called as cat. Next, this is another file which is under directory bo. Like that, I have each and every file under each directory, single directory. That is the meaning of a single directory for all users. Next, if I see here, the advantage is nothing but it is the simplest directory structure, easy and efficient to support. It is a simplest directory structure, it is easy and efficient to support. Next, disadvantages. It is not suitable for large number of files, more than one user, because the restriction, it tells that it is single level directory. Single level directory means a single directory for all users. So I cannot have more than one user. Next, because of single directory files require unique file names. Because I have a single directory file, the files require unique file names. Each and every file must be unique. The file names should not repeat. Next, difficult to remember the names of all the files as the number of files increases. When the number of files increases, I will be having a problem to, or as humans will be having problem to remember the file names. Next, grouping problem. You cannot group related files together. You cannot group together because it is a single level directory. These are certain advantages and disadvantages of a single level directory. Whenever the question is asked, you need to explain with the help of the diagram. You need to write what is single level directory, then write the diagram, take an example, explain with an example, and then write the advantages and disadvantages. Next, we shall see two level directory. What is this two level directory? separate directory for each user. Separate directory for each user. If you can see here, there is two level. Here in the previous diagram, if you see, you have only directory followed by files. It is single level. Whereas here, if you see here, it is user file directory is one area, next or one level, then master file directory is another level. This is nothing but your files. These are your different files. So separate directory for each user. So say suppose user 1. If I take user 1, under user 1 I have 4 directories, 4 user file directories, cat, bo, a, test. All these directories belong to user 1. Under this user 1, for each and every person I have each one file. So what is the advantage then? Efficient searching. Efficient searching. Why? Because say suppose I want to search this particular file abc.txt, I can just go and tell abc.txt. First I'll search in user 1. If I come here inside user 1, I have only these directories. Based on these directories, I can search the file easily. So if it is not present here, then go to user 2, search here user 3, user 4. Wherever the data is present, I can fetch that particular data. Next, no grouping capability. Grouping capability is not there. That is a major advantage. Next, resolves name collision problem. Resolves name collision problem. As you can see here, under user 2 and user 3, under user 2 and user 3, we have same directory names A and A. Even though the directory names are same, there is no collision. So because they are under different users. They are under different users. So there is no name collision. So resolves name collision problem. Next, isolation. This structure isolates one user from another. It isolates one user from another. Next, but disadvantage is that users may not be allowed to share or group file. The users may not be allowed to share the file or use a particular group, a particular file. This is the disadvantage of your two-level directory. Next, we shall see what is tree structured directory. Tree structured directory. As you can see here, first we saw single level directory, that is single level directory, one directory and followed by file. Here two level directories, master file directory, MFD and UFD, that is your user file directory. Next we shall see what is your tree structured directories. Tree structured directories, as the name suggests, tree. Tree means you have n number of levels. So a tree is the most common directory structure. It is the most common directory structure. The tree has a root directory. It has a root directory and every file in the system has a unique path name. It has a unique path name. And a directory contains a set of files or subdirectories. A directory is simply another file, but it is treated in a special way. All the directories have the same internal format. One bit in each directory entry defines the entry as a file, that is 0, or subdirectory as 1. Special system calls are used to create and delete the directories. Create and delete the directories. Say suppose I want to search this particular file which is present here, abc.txt. I have a unique path here, that is root. Under root I go to spell. From spell I come inside stat. I check here, it is not there. Next, stat mail. Next, after mail I come to program. Under program I come to list. Under list I have this particular file abc.txt. That is something related to your, similar to your relative path and absolute path concept. /root /spell /mail /prog /list /abc.txt. This is how a unique path is given for each and every file in your tree structured directory. So advantage is again efficient searching, grouping capability is there. I can group the files. Name collision problem is resolved. Name collision problem is resolved. Next, disadvantage. What is the disadvantage then? All files will not fit into hierarchical model. Many files cannot fit into hierarchical model. Some files may need to be listed under multiple directories. So some files under multiple directories we may need to list them. So accessing a file may involve many levels of directory or lookup. It can have many levels directory lookups. So this is the disadvantage of tree structured directories. Next, acyclic graph directories. What is this acyclic graph directory? An acyclic graph, as the name suggests, a graph with no cycles. A graph with no cycles. Acyclic means a graph with no cycles. It allows directories to share subdirectories and files. The same file or subdirectory may be in two different directories. The same file or subdirectory may be in two different files. The same file or subdirectories may be in two different files. It can be in two different files. That is, if here in the diagram, if you observe here, I have root. Under root I have dict and spell as two directories. Under dict also I have count as one directory. Under spell also I have count as another directory. So it tells that the same file or subdirectory may be in two different directories. You have common file here, which is been accessed by count. So same file under two different directories. So the acyclic graph is a natural generalization of tree structured directory scheme. It is nothing but the natural generalization of a tree structured directory. Next, we shall see how to write the general graph directory. This is how we write the general graph directory. Example of your general graph directory. Next topic is file system mounting. What is this file system mounting? A file system must be mounted before it can be accessed. So the mount is nothing but it is a procedure which is straightforward. The operating system is given the name of the device and the mount point, the location within the file structure where the file system is to be attached. So your mounted means your mount point will tell us where exactly I need to locate the particular given file structure, where exactly I need to attach the file. What is this? We'll see. A mount point is nothing but an empty directory. It is an empty directory. For instance, if you see here, if you observe, on Unix system always we start with root or home/home. So then access the particular directories there. Here also similarly, if you see here, this is the unmounted partition. This is the partition which I need to mount it under my root. This is my root or home. Under this home I need to insert this particular partition. So that is what it means. That is, next the operating system, after inserting it, the operating system will verify the device that contains a valid file system. So here if I see /user/fred/help. Similarly, if I want to access or insert this particular partition into this particular area, then it will be /root or /home/jane/doc. So this is what I mean to tell here. We have /users/fred/help. Instead of that, I'll be mounting this particular partition, that is /users/jane/doc. So this is what is called as file mounting system. So after this mounting is done, the operating system verifies that the device contains a valid file system. It does so by asking the device driver to read the device directory and verify that the directory has the expected format. Finally, the operating system notes in its directory structure that a file system is mounted into the specified mount point, that is whichever point it was specified to be placed in that particular place, whether it is mounted or not, the operating system is going to check. Now we shall see what do we mean by file sharing. What is file sharing? As the name suggests, sharing certain files. So sharing of files on multiple user systems is desirable. Sharing may be done through protection scheme, and it can also be done using your distributed systems, where your file may be shared across a network, that is many users can access a particular file. Next, network file system can also be used, which is a best example for your file sharing method. So file sharing is nothing but multiple users, user IDs, group IDs. User IDs, it identify users, allowing permission and protection to be per user, that is your user IDs. Group IDs, it allows the users to be in group, permitting group access rights, that is based on your read, write and execute permissions. Next, as I told you, we can have using networking, that is users networking to allow the file system access between systems. Next, we can also make use of client server model, which allows the client to mount remote file systems from servers, remote file systems to servers. Next, last is using distributed information systems. Also, we can share a particular file. So these are certain file sharing with respect to remote file system. One is your client server model, another one is your distributed information system. Next, last topic is your consistency semantics. What do you mean by consistency semantics? It is nothing but it specifies how multiple users access a shared file simultaneously. Multiple users are going to access a shared file simultaneously. So under this we have two things to remember. One is Andrew file system, another one is your Unix file system and session semantics. What is this Andrew file system? It is nothing but it is implemented as complex remote file sharing semantics. Complex remote file sharing semantics. Next, what do we mean by Unix file system semantics? In this Unix file system semantics, it writes, or whenever a write operation is done to an open file by a user, it will be visible immediately. To other users who are using that particular file. Next, one of the mode of sharing allows users to share the pointer of current location into the file. Whereas in your session semantics, whenever the file is open and write is happening, it is not visible to other users. Immediately it is not visible to other users. Once the file is closed, the changes made to it are visible only in sessions starting later. So this is what is meant by your consistency semantics. So consistency semantic, I repeat, how multiple users are able to access a shared file simultaneously. For accessing, we have two things. One is Unix file system, UFS, and one more is session semantics, or Unix semantics and session semantics. In Unix semantics, what happens? Whenever the user tries to write any content into the shared file, it is visible immediately to other users. Whereas in your session semantics, it is not visible to other users. So this is your first chapter of your file sharing concept. So in the next video, we shall see what is meant by file operation, accessing files and